Math quiz number 7. Get your formula sheets and get your calculators and let's do some math. As always, I do not own the questions in this quiz. They are sourced off the open internet. This video is for educational purposes. Question 1. If a pump is operating at 2,200 gallons per minute and 60 feet of head, what is the water horsepower? If the pump efficiency is 71%, what is the brake horsepower? A. 33.3 horsepower, 46.9 horsepower. B. 30.3 horsepower, 42.7 horsepower. C. 42.3 horsepower, 70.5 horsepower. Or D. 33.3 horsepower, 55.5 horsepower. Question number 2. The target dose for a system is 1.2 milligrams per liter. They are treating an average of 300,000 gallons each day. How many gallons of sodium hypochlorite, 12.5%, will they need to feed? Note, the specific gravity of the hypochlorite is 1.11. Is it A, 24 gallons, B, 2.6 gallons, C, 3 gallons, or D, 26.4 gallons? Question 3. What is the percent unaccounted water if a system records the following readings? The master meter reads 1.5 million gallons. The meter reading total is 965,000 gallons. Another 100,000 gallons were used for flushing, and 35,000 gallons were metered at a blow-off. Is it A, 27%, B, 25%, C, 30%, or D, 20%? Question 4. A basin 4 foot by 5 foot is to be filled to the 2.5 foot level. If the flow to the tank is 5 gallons per minute, how long in hours will it take to fill the tank? 1.2 hours, 0.16 hours, 1.4 hours, or 1 hour? Question 5. A jar test indicates that 50 parts per million of liquid alum will provide an optimum coagulant dosage. The alum solution has a specific gravity of 1.2. If the water plant treats on average 1.8 million gallons a day, how many pounds of alum will be used every 30 days? A. 27,021 pounds. B. 22,518 pounds. C. 19,027 pounds. Or D. 14,899 pounds. The answers are question 1, A, question 2, B, question 3, A, question 4, D, and question 5, A. All right, now let's get to the part where I solve the questions for you. Question number 1. If a pump is operating at 2,200 gallons per minute and 60 feet of head, what is the water horsepower? If the pump efficiency is 71%, what is the brake horsepower? First, let's pull our known and unknowns out of our word equation. So what you know is the pump rate was 200 gallons per minute, the head pressure is 60 feet, and the pump efficiency is 71%. What we don't know is the water horsepower or the brake horsepower. Here we have the formulas for water horsepower, which is flow gallons per minute times foot of head divided by 3,960, and brake horsepower, which is flow gallons per minute times foot of head divided by 3,960 times the pump efficiency as a decimal. So let's go ahead and plug these values in. So for water horsepower, you have 2,200 gallons per minute times 60 feet divided by 3,960. And for brake horsepower, you also have 2,200 gallons per minute times 60 feet divided by 3,960 times the percent 71 is a decimal, 0.71. So we did our multiplication in the brackets. So you have 132,000 divided by 3,960 for water horsepower. And for brake horsepower, you have 132,000 divided by 2,811.6. So you go ahead and divide. So the water horsepower is 33.33 and the brake horsepower is 46.9. So the answer is A. Question 2 was, the target dose for a system is 1.2 milligrams per liter. They are treating an average of 300,000 gallons each day. How many gallons of sodium hypochlorite, 12.5%, will they need to feed? Note, the specific gravity of the hypochlorite is 1.11. So first, let's pull our known and our unknowns out of the question. What you know is the dose is 1.2 milligrams per liter. The flow is 300,000 gallons per day. The specific gravity is 1.11 and the purity is 12.5%. What you don't know is how many gallons of sodium hypochlorite you need. So this is going to be a Davidson pie chart, feed rate pounds per day, so doses milligrams per liter, times the flow million gallons a day, times 8.34 pounds a gallon. And seeing we have an alarm, I'm going to answer it. Now that I've answered my alarm, I think what I was going to say is that seeing that we have the purity as a decimal, that remember when using the Davidson pie chart to find the quantity above the horizontal line, because we're looking for pounds per day, that you're going to multiply the 3 pi wedges below the line together, and then you're going to divide by the percent purity as a decimal. So here we have that written out. Feed rate pounds per day is equal to the dosage milligrams per liter times flow million gallons a day times 8.34 pounds per gallon divided by the percent purity as a decimal. So first, let's convert that 300,000 gallons to million gallons. So to do that, you're going to do 300,000 divided by a million. And you get 0.3 mg. So we're going to plug that into our formula. So we have 1.2 milligrams per liter times 0.3 mgd times 8.34 pounds per gallon. We're going to divide that by 0.125. So when you did all your math in the brackets, you get 3. So now we're going to divide that by the 12.5% as a decimal. So 3 divided by 0.125. And the answer is not 24. 24 pounds, and we're looking for gallons. So what do we do next? Next, we need to find the weight of the sodium hypochlorite. So we're going to do 8.34 pounds per gallon of water times the specific gravity of the hypochlorite, 1.11. That gives you the weight of 9.26. So we want the pounds to cancel out. So we're going to do 24 pounds per day times 1 gallon of sodium hypochlorite is equal to 9.26 pounds. We've set this up so it cancels out. So it's division, 24 divided by 9.26. And your answer is 2.59, and that will round to 2.6 gallons. Question 3. What is the percent unaccounted water if a system records the following readings? The master meter reading is 1.5 million gallons. The meter reading total is 965,000 gallons. Another 100,000 gallons were used for flushing, and 35,000 gallons were metered at the blow-off. So to do this, you do the total produced water minus the accounted for water divided by the total produced water. So you produced 1.5 million gallons. Your meter reading was 965,000 gallons. You're going to add that to the 100,000 gallons used for flushing and the 35,000 gallons that were metered for to blow off. And then after that, you're going to divide by 1.5 million. So let's add everything together in the bracket. So you have 1.5 million gallons minus 1.1 million gallons. And you're going to divide that by 1.5 million gallons. So do the subtraction. You have 400,000 gallons of unaccounted for water. Divide that by the 1.5 million gallons that you made, and you get 0.266. So you're going to times that by 100. That's 26.6, and that will round to 27%. Question 4. A basin 4 foot by 5 foot is to be filled to the 2.5 foot level. If the flow to the tank is 5 gallons per minute, how long in hours will it take to fill the tank? All right, let's pull our known and our unknowns out. So what you know is the length is 4 feet, the width is 5 feet, the height that you want is going to be 2.5 feet, your flow is going to be 5 gallons per minute, and what we're looking for is the time in hours. So to find the volume of a rectangle, length times width times height, you have 4 feet times 5 feet times 2.5 feet, which gives you a volume of 50 cubic feet, but we need gallons. Remember, there is 7.48 gallons in a cubic foot, and to do unit conversions, what you want to cancel goes on the bottom. So you're going to have 50 cubic feet times 7.48 gallons over a cubic foot. Your cubic feet will cancel out, and you get 374 gallons. So we're going to divide that volume by the flow. So 374 gallons times 1 minute gives you 5 gallons. So you're going to divide by the gallons, and you get 74.8 minutes. When you convert minutes to hours, there are 60 minutes in an hour. And again, unit conversion, what you want to cancel goes on the bottom. So 74.8 minutes times 1 hour over 60 minutes. So it's going to be division. The minutes will cancel out, and you get 1.246 hours. And the closest answer is 1.2 hours. Question 5. A jar test indicates that 50 parts per million of liquid alum will provide an optimum coagulant dosage. The alum solution has a specific gravity of 1.2. If the water plant treats on average 1.8 million gallons a day, how many pounds of alum will be used every 30 days? Let's pull our known and our unknowns out of the question. So what you know is you are looking for a dose of 50 parts per million. The specific gravity is 1.2. The flow is 1.8 million gallons a day. And what you're looking for is the pounds used every 30 days. So this is going to be a feed rate pounds per day question. So we have the dosage milligrams per liter times the flow million gallons a day times 8.34 pounds per gallon. And we're going to go ahead and put our specific gravity in that little bracket. So remember, parts per million and milligrams per liter are interchangeable. So 50 milligrams per liter times 1.8 million gallons a day times 8.34 pounds per gallon times the specific gravity of 1.2. So we're going to do our math, and you end up with an answer of 900.72 pounds per day. Now remember, this is over a 30-day period. So you multiply it by 30 days. 900.72 times 30. The answer is 27,021.6. The closest answer is A, 27,021 pounds. So that's another math quiz. Hopefully it's helped you learn. There's another alarm at my plan. I better get going. Thanks.